This is the Dive Into Discovery podcast, where curiosity meets insight, and every conversation uncovers a new layer of understanding.
Welcome to a deep dive, everyone. You know, that question that's probably older than, time itself. How did life on Earth even begin? We asked you to send us your thoughts, research, maybe even your theories on this one. And let me tell you, someone's been doing their homework.
Seriously.
Yeah.
We're talking about a question with more twists and turns than, the latest blockbuster movie.
Yeah.
We've got the classic primordial soup idea, this whole possibility of life taking a cosmic Uber from space. You name it, we're diving into it.
I'm not even kidding. We're talking about ancient fossils spilling the tea, scientists in labs trying to recreate the first spark of life, and get this, something called the RNA world. I mean, what even is that? Sounds kind of cool, though, right?
It does, yeah.
Honestly, prepping for this one, my mind was blown like a dozen times.
Well, to really wrap our heads around this, we've got to go way, way back. Picture Earth billions of years ago. I'm talking volcanoes going off left and right, an atmosphere that would make you, instantly explode.
Yeah.
Not exactly Instagram worthy.
Definitely not the picture-perfect tropical paradise we usually imagine, or the birthplace of life.
Not even close. This early Earth, it was a wild place.
Oh.
Hot, volatile, with an atmosphere that was basically a toxic cocktail of methane, ammonia, carbon dioxide. Yeah, the opposite of what we need to breathe.
Right.
But here's the thing. Even in that chaos, the basic ingredients for life, they were all there, just hanging out. Water, carbon, hydrogen, nitrogen, the essentials.
Well, okay, so we've got the ingredients, we've got this crazy kitchen all set up, but how do we go from a planet that sounds more like a death trap to, well, you and me?
That is the million-dollar question. The leading theory right now is what we call abiogenesis, the idea that life just kind of popped up from non-living stuff.
Think about it.
The right ingredients, the perfect conditions, and bam, life. And one of the most famous attempts to recreate this in the lab is the Miller-Urey experiment. You've heard of that, right?
Oh, yeah. Miller and Urey, the rock stars of the origin of life. Right. It's they basically bottled up what they thought was early Earth's atmosphere, zapped it with some electricity to, simulate lightning, and boom, amino acids.
How was that?
Like magic.
It was huge. This groundbreaking experiment that basically rocked the scientific world. I mean, think about it. They created the very building blocks of proteins in a lab. We were this close to cracking the code.
Okay, but there's always a but, right? It couldn't have been that easy.
You're right. It wasn't. The Miller-Urey experiment, as awesome as it was, had some issues. As scientists learned more about early Earth's atmosphere, they realized that their little simulation, it wasn't quite accurate.
So it's kind of like trying to bake a cake, but halfway through you realize, oops, I used salt instead of sugar?
Yeah, exactly. A very, very salty cake.
Yeah.
The recipe was off. Plus, it's one thing to make amino acids, but getting them to spontaneously assemble into these super complex proteins and then eventually form life that can actually make copies of itself, that's a whole other level of difficulty. It's like trying to build a skyscraper with just a pile of bricks and no instructions. Good luck with that.
So if this whole primordial soup idea isn't the be-all and end-all, what are the other contestants in this whole origins of life showdown? What else are we looking at?
Well, one theory takes us on a little trip to the bottom of the ocean, to these things called hydrothermal vents.
Okay.
Imagine these underwater geysers just blasting out superheated water and a bunch of chemicals. Yeah, not exactly a relaxing dip in the ocean.
Yeah, that's one intense spa day. Who needs cucumbers on a face mask when you've got molten rock and sulfur, right?
Right. And while, most life forms would be nope, not today, some scientists think these vents, they might have been the perfect spot for the very first life forms to show up.
Hold on. So instead of a nice, warm little pond, we're talking about a scorching, chemical-filled pressure cooker as the cradle of life. I'm starting to see why this whole thing is such a head-scratcher.
And it gets even wilder. There's this other theory. It's all about a little molecule you've definitely heard of, RNA.
RNA. You mean DNA's less famous cousin?
Exactly.
Okay. I'll admit, I always get those two mixed up.
Don't worry, you're not alone. It's like the chicken and the egg situation, but with nucleic acids. Think of DNA that's deoxyribonucleic acid, by the way, as the master plan, the instruction manual for building a whole living thing. RNA, which is ribonucleic acid, is the messenger, the one who takes those instructions and actually makes them happen.
Okay, so DNA's got the info and RNA puts it to work. Got it.
Exactly. You got it. But here's where it gets really cool. RNA can do something that DNA can't do on its own. It can be a
A
catalyst.
catalyst.
Yeah, which means it can speed up chemical reactions.
Wait, so RNA is like this multitasking rock star. It's storing genetic information and also making things happen in this primordial world.
Yeah.
Okay. No wonder it's got its own theory.
Right, and that's the RNA world hypothesis. It basically says that early life might have just relied on RNA, and DNA came later as like a more, stable way to store all that genetic info.
So instead of life starting with DNA, it might have started with its more like adaptable cousin. Okay, this is blowing my mind.
It really makes you think about like the core of life, right?
Yeah.
But we got to remember, this is just one theory out of many. We're not even close to the end of this debate.
And speaking of debates, are we being too like Earth-centric here? What if, and
Yeah.
hear me out on this, what if life's building blocks didn't start here on Earth, but came from, somewhere a bit more extraterrestrial?
You're talking about panspermia.
Yeah.
That's a whole other story. Buckle up. Panspermia. It kind of sounds like something you'd order at a fancy space restaurant, right?
Yeah.
But really, it's this idea that the very first ingredients of life, those essential building blocks, they didn't actually form here on Earth, but hitched a ride from space.
Okay, are we talking about comets with tiny little delivery drivers bringing us packages of organic molecules? How does this even work?
Not quite like that. Think about it.
Right.
You've got meteorites, right? Those chunks of space rock that are constantly, like, crashing into early Earth.
Right.
Well, we know that these meteorites, they can carry some pretty interesting stuff, including, get this, organic molecules, like amino acids.
Wait, hold up. We're finding the same building blocks of life that we have here on Earth, but inside rocks that have been, floating around in space. That's wild.
It really is. And yeah, it kind of makes you wonder, right? If these complex molecules are already just hanging out in the universe, maybe, just maybe, they played a role in getting life started on our little planet.
So instead of life emerging from some primordial soup, it's more like Earth got this, super important cosmic care package. The universe sends over the starter kit, and Earth is like, all right, I'll provide the greenhouse.
A greenhouse in a really rough neighborhood, you mean? Don't forget, early Earth was still pretty chaotic. But yeah, it's a seriously cool theory, and these organic molecules we're finding in meteorites, they definitely add some weight to it.
I gotta say, this is all pretty mind-blowing, but let's bring it back down to Earth for a sec. We've been throwing around a lot of theories, but do we have any, solid evidence? What about fossils? Those seem pretty important, right?
Absolutely.
Ah.
Fossils are like little windows into the distant past, and they give us actual proof of what life was like billions of years ago.
And when it comes to the oldest life on Earth, we're talking about those crazy stromatolites, right?
You got it.
I remember seeing pictures. They look like something you'd find on a different planet.
They really do have this alien look to them, don't they?
Yeah.
Stromatolites are basically like ancient cities that were built by microorganisms. They're these layered structures formed by colonies of single-celled organisms, and some of them go back at this 3.5 billion years, maybe even older.
3.5 billion years. To put that in perspective, that's almost as old as my grandma's favorite chair.
Yep.
But really, what can these ancient fossils actually tell us about the very first forms of life?
Well, for one thing, they tell us that life on Earth, it got started way earlier than we thought. We're talking just 1 billion years or so after the planet formed.
Wow.
And there was already life, like thriving microbial communities just doing their thing.
Life finds a way, as they say. It's amazing how quickly life seemed to pop up once Earth became even a little bit livable. But okay, if we're thinking about panspermia, this whole idea that life's ingredients came from space, why doesn't life on Earth look, well, a little more alien?
That's a great question. And it takes us to one of the biggest mysteries in the whole origins of life story, the mystery of chirality.
Okay, chirality. That's about the handedness of molecules, right?
Exactly.
Like my left hand and right hand, they're basically mirror images, but I can't wear a right-handed glove on my left hand. It just doesn't work.
That's the perfect way to think about it. So many molecules, even those amino acids that make up proteins, have this handedness that we call chirality. They come in two forms that are mirror images of each other, just like your hands.
Okay.
But here's the thing. Life on Earth pretty much only uses left-handed amino acids and right-handed sugars.
So even though these molecules could be either way, life was like, nope, I'm picking a side. Why would it do that?
It's a question that has been bugging scientists forever. Some think that this whole chirality thing, this preference for left-handed amino acids, might be a huge clue about where life came from.
Mm-hmm.
What if, and stay with me here, the very first building blocks of life with their specific chirality were already in the material that landed on Earth? So it's not that life on Earth made a choice, it's that it was already decided way before based on where those building blocks came from.
So it's like the universe sent us a cake mix, but it only makes left-handed cakes. Like, that's both super weird and strangely specific.
Right. But if that's true, then it just leads to more questions.
Right.
Why that specific chirality? Where did those molecules come from in the first place? These are all things scientists are still trying to figure out.
So we've got this cosmic mystery on our hands, literally. But since we're already talking about connections and, like, ancestry, you mentioned something earlier, LUCA, the last universal common ancestor. What is that exactly?
Oh, yeah. LUCA. If we could hop into a time machine and meet LUCA face to face, it probably wouldn't look like much. Think of, like, a single-celled organism, way simpler than even the simplest things alive today.
Not exactly winning any beauty contests.
Probably not.
Yeah.
But don't let that fool you, because LUCA is super important in the story of life. It's the ancestor of every single living thing on Earth. From the tiniest bacteria to, well, us.
Wow. Now that's what I call an extensive family tree. I'm related to a bacteria. Yeah. I knew that one distant cousin looked a little pale. Okay, but really, what do we actually know about this LUCA?
Based on what we've learned from genetics and those ancient fossils, scientists believe that LUCA was probably a single-celled organism that lived in a hot, oxygen-poor environment, maybe near those hydrothermal vents we talked about before.
Talk about a tough life. But I guess when you're, like, the ancestor of everything on Earth, you've got some serious bragging rights.
Totally. It's pretty amazing when you think about it. Every single thing on this planet, from giant trees to tiny mushrooms, we can all trace our family tree back to this one little organism.
It really puts the connected in all life is connected, doesn't it?
Right.
But I bet there are still a ton of debates and research going on in this whole origins of life field.
There's got to be, right? I'd bet my last dinosaur sticker on it. It feels like we've only dipped our toes into the primordial soup of this whole origins of life thing. So, like, what are the biggest challenges those researchers are facing when they try to put this puzzle together? Well, imagine trying to solve a mystery, right? But this mystery is, like, 4 billion years old, and the crime scene is the entire planet.
And I'm guessing the witnesses aren't exactly lining up to give their statements, huh?
Not a single one.
Right.
We only have the clues they left behind,
Yeah.
Fossils, chemical traces, and those are super hard to decipher. Plus, we're talking about stuff that happened over, like, ridiculously long periods of time, way longer than we can even really imagine, let alone try to recreate in a lab.
It's like trying to, I don't know, rebuild Rome in a bathtub. You might get the general idea, but it's not going to be exactly accurate.
Exactly.
So if the primordial soup, the hydrothermal vents, even this whole panspermia thing, if those aren't the whole story, what else are scientists looking at? What are the other options?
One theory that's becoming really popular is the lipid world hypothesis.
Okay.
Now, instead of focusing on RNA or DNA, this one says that life may have started with something way simpler, like these self-replicating molecules called lipids.
Lipids. Okay, hold on. Aren't those like fats and oils? Why would they be involved in the origin of life?
Okay, so think about it. Lipids, they can do this cool thing where they spontaneously form membranes in water. Like, picture a soap bottle, right?
Okay, yeah.
That thin, kind of stable film. That's basically a lipid membrane. Now imagine those forming way back in the primordial soup, creating these little compartments that could protect those even simpler molecules inside.
So like a really, really early version of a cell membrane?
Exactly.
A safe space for life to kind of get started?
Exactly. These compartments, they could have been like little incubators, bringing molecules together, helping reactions happen, and eventually paving the way for more complex life to, do its thing.
It's like the answer was right there under our noses the whole time. Those basic little cell membrane building blocks could be the key to the whole thing. And speaking of unexpected places, I remember reading something about a clay hypothesis. What's that all about?
Oh yeah, the clay hypothesis. It might sound a little out there, but stick with me. So clay, it's got this super unique structure. It's porous with a charged surface, kind of like a natural scaffold.
A scaffold for what, exactly?
For those essential organic molecules. The charged surface of the clay, it could have attracted and concentrated them, bringing them close enough to interact and form more complex structures. It's like clay was like the original matchmaker for those prebiotic molecules, getting the party started.
That's incredible. Deep sea vents, meteorites from space, and now clay. Who knew? It seems like this whole field is bursting with possibilities.
It really is. And honestly, we've barely scratched the surface. Some researchers are looking into things like lightning or UV light as energy sources that could have kicked off the formation of those early building blocks. Others are wondering if early life might have been powered by sulfur, especially around those hydrothermal vents we were talking about.
It seems like every time we answer one question, like 10 more pop up. It really makes you realize just how much we don't know about, well, anything, even the very beginning of life itself.
And that's what's so exciting. It's all about discovery, about challenging what we think we know and pushing the boundaries of our understanding.
It's like this amazing reminder that we're living in a universe that's full of mysteries, just waiting for us to uncover them. And hey, maybe someday, some of you listening right now, maybe your questions will lead to the next big breakthrough in this whole origins of life puzzle. This deep dive might be over, but the exploration never really ends, does it?
What did you think of this week's episode? We'd love to hear your thoughts in the comments. Don't forget to join us next time as we dive even deeper. And as always, stay curious, because you never know what discoveries are just around the corner.